National Electrical Code Section 45.5 current addresses overcurrent protection for conductors supplied from a power supply conductor to a Class 2 or Class 3 circuit. This section is important for ensuring the safe and reliable operation of low-voltage power circuits. The intent is to protect small-gauge conductors, like number 18 American wire gauge, from overcurrent conditions that could lead to overheating and potential fire hazards. Let's delve into the specifics of this code section. Firstly, it is crucial to understand what constitutes a Class 2 and Class 3 circuit. Class 2 and Class 3 circuits are low-voltage, low-energy circuits that are designed to limit the risk of electric shock and fire. They are commonly used in applications such as control circuits, signaling circuits, and power-limited circuits. The NEC defines the power limitations and voltage requirements for these classes of circuits. Secondly, the Type CF conductor designation refers to a specific type of flexible cord or wire. The NEC specifies the allowable uses and limitations of Type CF conductors. It's vital to use the correct type of conductor for the application to maintain code compliance and safety. Now let's get to the core of the question, which is the overcurrent protection requirements for a number 18 Type CF conductor supplied from a power supply conductor to a Class 2 or Class 3 circuit. According to NEC Section 45.5 Con, this conductor must be protected by an overcurrent device rated not over 20 amps if the conductor length does not exceed a certain limit. It is crucial to consult the specific tables and references within NEC Section 45.5 current to determine the allowable conductor length for a number 18 Type CF conductor with a 20 amp overcurrent protection device. These tables take into account factors such as the conductor's insulation type, the ambient temperature, and the method of installation. These factors collectively affect the conductor's ampacity or current carrying capacity. The overcurrent device, which could be a fuse or a circuit breaker, is designed to interrupt the circuit when the current exceeds its rated value. This protects the conductor from overheating and potential damage. The 20 amp rating is the maximum current that the overcurrent device will allow to flow through the conductor before it trips or blows. It is critical to select the correct overcurrent device rating to ensure that it protects the conductor adequately without causing nuisance tripping. When determining the appropriate overcurrent protection for a number 18 Type CF conductor, several considerations must be taken into account. One consideration is the ampacity of the conductor itself. Number 18 American wire gauge conductors have a limited ampacity, which is the maximum current they can safely carry continuously. This ampacity is determined by factors such as the conductor's insulation type, the ambient temperature, and the method of installation. You must ensure that the overcurrent device rating does not exceed the conductor's ampacity. Another consideration is the load that the conductor is supplying. The load should not draw more current than the conductor and the overcurrent device are rated for. If the load draws too much current, it will cause the overcurrent device to trip, interrupting the circuit. It is also important to consider the potential for short circuits or ground faults in the circuit. These faults can cause a large surge of current to flow through the conductor, which can quickly overheat it and cause damage. The overcurrent device must be able to quickly interrupt the circuit in the event of a short circuit or ground fault to protect the conductor. In addition to the overcurrent protection requirements, there are other NEC requirements that must be followed when installing Class 2 and Class 3 circuits. These requirements include proper wiring methods, grounding, and separation from other circuits. It is important to consult the NEC and other relevant codes and standards to ensure that the installation meets all applicable requirements. Here are some additional points to consider when working with Class 2 and Class 3 circuits. Firstly, always use listed or labeled components that are suitable for the intended application. Secondly, ensure that all wiring connections are made properly and are secure. Thirdly, protect conductors from physical damage. Fourthly, properly ground the circuit to minimize the risk of electric shock. Fifthly, follow all applicable safety precautions when working with electrical circuits. In summary, NEC Section 45.5 COM provides important guidance on overcurrent protection for conductors in Class 2 and Class 3 circuits. By understanding and following these requirements, you can ensure the safe and reliable operation of these low-voltage power circuits. Always consult the latest edition of the NEC and other relevant codes and standards for the most up-to-date information.